In this video, you will be learning about coterminal and reference angles. So coterminal angles, co meaning both, so coterminal angles are angles that have the same initial side and the same terminal side, but they have different measures. So I could have an angle here and let's say that's 120 degrees, and my initial side is here, my terminal side is here. But I could also measure that in a clockwise direction and get a negative. So that's the kind of thing we're going to be talking about here. So finding all coterminal angles and making generalizations is our goal. We're going to let theta be the given angle. So if I expand upon this example here, and I have my initial side and I have my terminal side, I have this angle, and this is a positive degree. So this is going to be my theta. Then I could also have an angle that's positive, but it has more than 360 degrees. And so it has the same initial side, so it's going to start there. So there's my initial side, because that's where it starts. But this time it's going to go around and then back around. So it still has the same initial and the same terminal side as my first angle, my theta, but now I have theta, and I'm going to call this theta 1, sub 1, because it's more than the 360 degrees, but still meets the criteria of having the same initial and the same terminal side. In fact, I could create an infinite number of those kinds of things. I could go around twice instead of just once, adding 720 instead of just the 360. In fact, I could add any integer number of circles around. And so to show that in general terms, I have my theta in general terms equals my original theta plus that 360 degrees times any integer. So that k represents any integer. Now notice that my original theta, so this theta right here, must be between 0 degrees and 360. Now all of this could also be done with radians. And so let's see what that looks like. So I would have my theta, and this time in radians, so in other words with pi's. And I'm going to have my original, same, plus, instead of my 360 times k, instead of 360, I'm going to use 2 pi times k. And again, k is any integer. So this was the positive, but then I also could have a negative. So I could also, of course, have gone around this way. So I'll show you in our examples on how we can account for that as well. Okay, so in our problems, find and draw one positive and one negative coterminal angles with the given angle. Then find all the angles that are coterminal with the given angle and make the generalization. So to start out, we're going to recognize that 70 is between, it fits the criteria of being between 0 and 360, so we can just use it. And so this is our theta. Then our theta 1 is going to be 70 plus our 360, which would give us 430 degrees. So this would be an example of our positive coterminal angle with our original. And then our other one our theta 2, is going to be 70, and we're going to subtract 360. And that would give us a negative 290 degrees. So this one is our negative version. Now our generalization is our theta sub n is going to equal our original plus our 360 degrees times k. So our original was 70, so it would just be 70 plus 360 times k. So in other words, if k was 2, then it would be 70 plus 720. If k were 3, you see how to do the math. Okay, so let's draw this. So we're going to start with our original, and I'm going to draw my original here as 70. So that's going to look something like this, would be my original theta. Then my next one, I'll do in blue. And it's still a positive, so I'm going to go in the positive direction, which means I'm going counterclockwise. So around, same initial side, same terminal side. And then my last example is the negative, same initial side, same terminal side. Okay, let's do one that's in radians. So if I look at this one, I want to start out, notice that our criteria was it was a positive angle. So let's start out by writing this, let's rewrite it as a positive angle. So I'm going to put that out, so just to remind you is to rewrite as positive angle. So in order to do that, my theta is going to equal my negative 5 pi over 3 plus 6 pi over 3. Now where that came from is, if I look at my little coordinate plane here, remember this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi again. Well, I'm trying to add enough to make this positive, so I'm adding 2 pi, so I'm taking it all the way around, and I'm doing it in thirds so that my denominators are the same. So that makes it pi over 3, okay, because this is just equivalent to the 2 pi. So I'm going to use my theta as pi over 3. And then I'm going to do exactly what I did up here, but instead of degrees, I'm going to use my radians. So I'm going to start out with theta sub 1, my theta, plus 2 pi. So remember, it's 2 pi. And I'm going to use, as a matter of convenience, the 6 pi over 3, and I get 7 pi over 3. So that's my first example. So that's going to be my positive. And then to do my negative, this time I'm going to subtract 2 pi, and it gives me this. But notice that was what I started with. So what I'm going to do is I'm going to subtract another 6 pi over 3, and that gives me negative 11 pi over 3. Okay, so let's see what that looks like. So when I do my original, remember I'm working with this one, so it's going to be pi over 3. So this is pi over 4, pi over 3 is a little bit more, so it's going to be like this. So this is my theta, my pi over 3. And then my, this one, my theta 1, is 7 pi over 3. So what I'm doing here is, if I go around once, Okay, that's 6 pi, and then one more, 7 pi. Alrighty, so that's my theta 1. And then the last one, my last example here, is this negative 11. Well, negative 11, if I do that, 3 divides into 11 2 times and 2/3. So you'll see what happens. Remember, I'm going in a negative direction. So I'm going to go 2 pi and 2/3. So I'm going around, and I'm going in a clockwise direction, and then 2/3 back around. Okay, so I'm going right there, and that's my theta 2. Now what I haven't done yet is write my generalization, but it's very similar to what we did earlier. And I'm going to use this one. Oops. 3 plus, and then, 2 pi. Okay, and then so the negative 1 here. Why don't you pause the video and try that one, and then come back and I'll have the answer for you.